Our sixth lesson from Unit 4A is how to explain and use the properties of angles created by chords. So we have learned two types of angles so far. We have central angles, which their vertex is coming from the center. We have inscribed angles, which means their vertex is on the circle. And now we have in angles. So an in angle is formed by an intersecting chord. So we know that they are in angles because the vertex is inside of the circle, but it is not coming from the center. Remember, if it's coming from the center, those would be central angles. The formula for in angles is the measure of the angle equals half of the sum of the included arcs. So we know that half is just dividing by 2. And the included arcs just mean the arcs that are across from each other, and we know sum means addition. So we look at our picture. If I'm trying to figure out this angle, so angle BED, I just say what two arcs are across from each other. So this would be arc BD plus arc CA would give you the measure of angle BED. So you always look across from those angles to see which arcs to add together. So if I wanted to figure out angle CEB, this would be arc C to B plus arc D to A divided by 2 would give you the angle. So go ahead, pause the video, and see if you can figure out example number 1. The very first thing you should have figured out is that the two arcs that are directly across from the angle that we wanted. We wanted angle BED. The two arcs that are directly across from that is 70 and 170. And we always want to do the big arc first plus the small arc. And since we did not have any variables on the left-hand side, you can go ahead and plug that into a calculator. If you're doing an online calculator, such as Desmos, then you can click the fraction button on the right-hand side and just click 170 plus 70 on top, divided by 2. You should get 120. Go ahead and pause the video and see if you can figure out example number 2. I will tell you to be careful that it's always the big arc plus the small arc divided by 2 always equals the angles. So the first one should always be the big arc, second should always be the small arc, and it should always equal the angle. Sometimes we know the angle, sometimes we don't. Okay, hopefully you're able to set it up like this. We have an in angle because the vertex is inside the circle. The two arcs that are directly across from it is 99, which is the big arc, and the other arc is our x. So that's why we have x in the small arc position, and then we have 72 in our angle spot. So now to figure this out, just like we did on all of the other problems in our other units, we're going to make this side into a fraction. We're going to cross multiply. We get 144. And 1 times 99 and 1 times x is the same exact thing. And then we subtract our 99. We get x equals 45 degrees. Is our small arc. Okay, pause the video and see if you can figure out example number 3. I will tell you a hint. You might have to figure out this angle first before you can figure out x. Very first thing you should have figured out is that the angle that these two arcs actually go to. In the middle, I went ahead and labeled angle Y. So the big arc is 164 plus the small arc, which is 68, divided by 2 would give me this mystery angle Y. So we figured out that this angle in the middle is 116. And just like in geometry, we always look for supplementary angles. So we see a straight line and they are adjacent. So we know we can say 180 minus that 116 and x equals 64 degrees. Okay, last one. So go ahead and figure out example number 4 for x and y. I went ahead and drew my arrows for angle x. And I got the big arc was 148, the small arc was 70, so angle x is 109. And you could have either drew those arrows across from angle y to figure out the big arc was 85 and the small arc was 57, or you could just simply say 180 minus x, which is 109, we also get 71. So angle x is 109, angle y is 71.